Alright, back with another one. This is 21J.1, question 3. Show that 4x plus 1 over x minus 1 may be written in the form 4 plus 5 over x take 1, and then show that the integral equals that. Well, these are fun ones. I remember doing these back in year 11 with you guys. Here we've got 4x plus 1 over x minus 1. Now, I want to get it into this form 4 plus 5 over x minus 1. All I'm really going to do is focus on getting that 4. It's going to happen if I have an x minus 1 that I can factor. Why do I need x minus 1? Because that's the same as the denominator, isn't it? You can see x minus 1 on the denominator. So I want to create this x minus 1 term. It's a bit like when we complete the square, we want to create the perfect square. Here I want to create the factor that's going to cancel. But of course I've cheated, haven't I? Because if I expand that, I've got 4 times x is 4x, but I've also got 4 times negative 1 is negative 4. I've just put a negative 4 into the numerator. I can't do that unless I go ahead and add 4 to make up for subtracting 4. If I add 4, now when I expand it, they'd cancel out. That wouldn't be too bad. And I still need the plus 1, don't I? Plus 1 there. Now, because you guys are great at your addition of fractions, and no one would ever cancel the wrong bits, you would realise that I could write this as the sum of 2 separate fractions. 4 plus 1 would be 5 over the same denominator, x take 1. Now you can see how we can easily get to the answer. 4 plus 5 over x take 1. First part of the problem done. Not so bad, is it? Alright, let's go ahead and find the integral. Now I'm going to try and work over this side of the page. So therefore, the integral from 3 to 5 of 4x plus 1 over x take 1 dx. And we know that it's actually going to be equal to the integral from 3 to 5 of 4 plus 5 over x take 1 in terms of x. This integral we can find, so this is looking pretty easy. 4 must have come from the function 4x. 5 over x minus 1 must have come from 5 ln natural log of x take 1. I could put absolute value there, but it's not needed in this case, so we'll just leave it like that. Let's just check and make sure that would work. If I did 5 times, would it be 1 over x minus 1? Yeah, that would come from log x minus 1. There's no chain rule, nothing else. I'd have to cancel out because the derivative of the inside is 1. So that's all good. Now we just sub in the numbers and see what we get. 4 5s are going to be 20 minus 5 natural log of 4. Subtract 3 4s are 12. Why did I write minus there? It's plus. Plus 5 times the natural log of 3 take 1 is 2. Alright, we can neaten this up a little bit. This is 20 plus the natural log of 4 to the power of 5, or 5 log 4. Look, I could just get them into logs and do the subtraction, but when I look at it closely, look at that. Log of 4, 4's another power of 2, isn't it? We've got a 2 there. I could write 4 as 2 squared and then put the power out the front. Why don't I do it that way? So it's plus 10 times the natural log of 2 minus 12 minus 5 times the natural log of 2. 20 subtract 12 indeed gives me 8. 10 log 2 minus 5 log 2 is 5 natural log of 2. And we're done. That one was nice and easy. See you in the next one.